Once again with a new video. This is Maths by Viraj. Right, children. Now for today's particular sum that we have, these are the three theories that you should know. The first theory is opposite angles of a cyclic quadrilateral add up to 180. This is a circle. Inside the circle you have a quadrilateral. What is a quadrilateral? A four-sided polygon. What is a polygon? A polygon is a closed figure drawn using straight lines. Since it has four sides, we call it a quadrilateral. Inside the circle, cyclic quadrilateral. And the opposite angles of a cyclic quadrilateral, they add up to 180. In this case, x plus y equals 180, p plus q equals 180, and the sum of all interior angles, as you know, is 360. Having that said, now, this is not much of a theory, but it's better to have it as an understanding before the sum. You see that AB, BC, and AC, these are three codes that we have. In these three codes, these two sides, AB and AC, they are equal. Therefore, the angle ABC is equal to the angle ACB, making this an isosceles triangle. Furthermore, the most other important, last but not least, theorem that we have is alternate segment theorem. In this case, there is a triangle that is drawn inside the circle and a tangent drawn to the vertex of the triangle. Remember, the tangent should be drawn to the vertex or to a vertex of a triangle. Here, the exterior angle is equal to the interior opposite. Exterior angle is equal to the interior opposite. And also here, exterior angle is equal to the interior opposite. So this is what we call the alternate segment theorem. Here the sum, you have a cyclic quadrilateral. We are supposed to find the angle BCD. Children, understand that we can draw codes within the diagram. Don't think that we can't. Of course, we can. So I have joined B and D. What was the reason for this? I have understood that there is an exterior angle 71. Using the knowledge that we have before, I have shown you today. These two angles are equal by what? Alternate segment theorem. Therefore, I can say that this particular angle is also 71. That angle is also 71. So I write angle ABD is equal to angle ADT, which is 71. The reason, alternate segment theorem. In short form, I have written. Furthermore, I can also say that this particular angle is also 71. What is the reason for that? Well, now we write, consider triangle ABD. In triangle ABD, it is already given to us that AB equals AD. Therefore, angle ABD is equal to angle ADB, which is 71. What is the reason for this? Angles of an isosceles triangle. Be that as it may, 71, 71. Now I have understood that from this particular exterior angle 71, I have calculated these two values. Those are the only two values that I can calculate. Initially this and then this. Because we have to start off with whatever the angle that is there that we can calculate and get the answer from. So since BCD and BAD are opposite angles of a cyclic quadrilateral, if I get this angle, I can easily get the value of BCD. Right, now what I meant was, in a cyclic quadrilateral, the opposite angles add up to 180. They are in if I could get the value of BAD, then from 180 I can subtract it and get the value over here. So let's see now what is BAD. Angle BAD is 180 minus 71 plus 71. BAD is 180 minus 142. Therefore, angle BAD is equal to how much? 38 degrees. What is the reason? Angles in a triangle add up to 180. So now we have calculated the value here, BAD as 38 degrees. Simple. Children, having known the angle BAB as 38, we know that opposite angles of a cyclic quadrilateral add up to 180. Therefore, BCD is 180 minus 38. BCD is equal to 142. Final answer. The reason for this is opposite angles of a cyclic quadrilateral add up to 180 degrees. So we have finally calculated the value of BCD, which is 142.